Hello, everybody. Welcome to the DePIN podcast. I'm your host, Tom Trowbridge. I'm thrilled to be here with Daniel, the founder of Onocoy, also the president of the Onocoy Association. Welcome, Daniel.
Hey, Tom. Thanks for having me.
So listen, Daniel, talk to us about Onocoy. What is it that you guys do?
Sure. So with Onocoy, we're active in the space of high precision GPS. High precision GPS, where we can take the GPS accuracy of the GPS that you know from your phone and from your car from 2-meter level accuracy down to centimeters. The way this works is that we're compensating atmospheric delays as the signal travels from the satellites down to the Earth. We can compensate those delays by measuring that in a decentralized manner by having stations on the planet which measure those satellite signals. And then that data in turn can be used to improve the accuracy of moving devices such as tractors, drones, autonomous vehicles, and the like.
Wow, that's super interesting. And I think, there's several projects in the DePIN space targeting location. And it strikes me that this is one of the areas that DePIN is incredibly well suited to offer a superior solution to centralized providers, current providers. And so you referenced the accuracy improvements that you guys have, which is a order of magnitude improvement, maybe 2 orders of magnitude, right? So that's remarkable. Help us understand that and why a DePIN solution is the way that makes that operate versus the centralized existing infrastructure.
Look, the thing is, the physics side, so compensating atmospheric errors in order to improve accuracy, that's been well known. That's been done for the last 20 years, and there's about 15, 20 large players who offer such services in a very traditional, in a centralized mode. They often do this for high value, low volume applications, things like surveying, mapping, and with business models that are suitable for such applications. Now, those operators, what they typically do is they operate their own stations. So every 50, every 100 kilometer, they put up a station. So that's typically antenna like this one, and a small box which goes alongside. And in a professional manner, that would be super redundant, backup power supplies, backup communications channels. So a rather costly piece of equipment, and they are putting that in areas where they want to provide service. That means they have quite a bit of capital expenditure for acquiring such devices, for installing them, but then also for maintaining that on a yearly basis. Not only does it need power and connectivity, there need to be service technicians, which service that. There's leases to be paid for where it's being installed and so on. So it's traditionally seen a rather expensive undertaking if you want to cover, say, a country or even a continent like, say, the North America or Europe. That is a pretty costly exercise. And everybody is doing that in competition with each other. So the big players, they operate mostly their own networks, and they don't share that with their competitors because they are competitors. And that's where DePIN comes in, and that's also how we position ourselves. So we are orchestrating a rollout of a decentralized network by incentivizing individuals to buy such a device, so such an antenna and a small box, which looks something like this, to operate that, put the antenna on the rooftop to operate that and provide us the data, and we're in return giving the cryptocurrency. And through that, the investment that traditionally would be needed by a centralized organization is shared amongst a large community of individuals who do that for the purpose of earning cryptocurrency, for the purpose of participating in something good, for the purpose of the use cases, because in many cases they themselves also need that data. And that's why a DePIN approach is a very feasible one, eventually allowing the whole industry to share a one global decentralized utility network that everybody can build on top, rather than building a new proprietary closed system for yet another application, which is what traditionally has been done. But with a horizontal approach, we are able to provide into or to supply data into those manufacturers and those service providers today who have their specific business models for, say, agriculture, for marine, for automotive applications.
Sounds like an ideal DePIN use case, right? And so this backs me up to two things to get into. But first, I have to hit one of my pet kind of comments. Also, you guys, I would classify you as 100% squarely in the DePIN network. How would you define DePIN? Just to back it up for a second, for people that the space is expanding, people are jumping into it. Do you have a definition that you use for it? Because my definition, you guys are squarely in, but I'm kind of curious if you have one of those.
I think the abbreviation DePIN is spot on. Decentralized physical infrastructure network, so something physical, something which is of use as an infrastructure orchestrated in a decentralized manner. There was, before the term DePIN was coined, there was also the term TPIN for token incentivized physical infrastructure networks. I read the token incentive also into DePIN, although in a stronger definition, or in a narrow definition, that's not necessarily the case. I think in the end it boils down to community operating nodes and in an orchestrated way, so that it builds a network, that it builds a utility for a demand side to use. And I think that's common across all the DePIN networks. You have a supply side and you have a demand side. And the goal is to reach at least a equilibrium, that's the supply. So also from a tokenomics perspective, that the tokens that go to the supply are outweighed by the demand side. And in our case, in the GPS industry, there is a large established industry behind using such data services.
No, I was going to say everything you said makes complete sense. There's a lot but there's more, I guess I would say, controversy or more expansive definitions of some of those words than might be obvious. And so what I use is a crowdsourced physical infrastructure secured by, crowdsourced physical infrastructure in a common network secured and incented by crypto economics, which is
Absolutely.
Exactly what you would think. And I don't think that's controversial to you, but for some people, believe it or not, it is. Let's talk about your background, because this is a pretty specific niche area. And it seems like you have been working in this area for quite a while. And that's one of the things I love about DePIN space is we've got find a number of people, expert and specialists in particular fields, that then gravitate to this space as the most effective way to deploy the technology that they are most experienced in. And it sounds like you fit in that category. Let's learn about your experience a little bit.
So I'm pretty new to the whole Web3 crypto DePIN scene. I started studying this when I learned about the Helium project around 3 years ago. And I was just fascinated by that idea, how you can orchestrate a global network, like in the Helium case, with an approach that just makes perfect sense. Now, my background is all of my career, I've been in satellite navigation. I started a first startup here in Zurich, Switzerland in 1997, a company called uBlocks. And in that company, me and two co-founders, we built up a market dominant player of GPS chips. So actual electronics. We would be building chips, so semiconductors, we would be building modules and sold them on a global market. Throughout that, we've been able to reach market leading positions in a number of professional applications, drones, cars, robotics, but also simple things like fleet management and telematics and tracking systems for all sorts of applications. In that company, we IPO'd in 2007. We built up a unicorn, reached market cap of $1.6 billion in 2016. And it's been a great run, and that company is still around, dominating many of the more professional applications. Me personally, I left 5 years ago. I turned 50. I thought I've seen it. But I'm a satellite navigation nerd, and I'm again back in by now the third startup, which is Onocoy. where we're not looking at the hardware side of things. Our belief is there's plenty of companies in the industry who build the hardware, who build the chips, who build the devices, the boxes. But on the services side, there's that problem that I mentioned earlier of CapEx, OpEx that needs to be solved. And here we can make a difference by doing a horizontal layer DePIN platform that anyone can build on top.
Interesting. Well, I mean, that sort of hits exactly the key points of so many leading projects, which is helium inspiration, expertise in a particular vertical that then deploys blockchain and crypto economics and the DePIN kind of ecosystem, if you will, to provide a solution superior to the traditional centralized competitors. And I mean, that sort of hits all the points. And there's a number of projects like that, which I find really, super compelling. Help us understand the scale of what the centralized competitor would have to deploy versus what you can deploy in a decentralized way, in terms of what the each of the devices cost, maintenance, how many you think you need to deploy to cover X continent, country, mile, whatever the metrics, however you think about it, just to give people senses of scale here.
Mm-hmm. Sure. So if you look at the major players, that's companies like Trimble, Hexagon, Swift Navigation, Point One, and various others on a global scale, but there's also national networks, regional networks. The typical thing that they do is that they're setting up a station every 50 to 100 kilometers. The data that is being received by such an antenna can be used by mobile devices in the vicinity of, say, 20 to 50 kilometers, and it enables a rapid determination of the location down to sub-centimeter accuracy. If you go further out, it takes longer. So there is a trade-off. The traditional companies, they like, for investment reasons, they'd like to have an as coarse spacing as possible, because that's cost, that's investments, and that's also maintenance costs. Whilst from a performance perspective, you like to have an as dense network as possible. So you'd rather want to have every 20 kilometers a station, ideally even in a redundant setup, so that if one goes down, that you still have another one. And I think that the trade-offs that the traditional providers have are quite different than what you can do in a decentralized mode. So a traditional provider, they have redundant backup supplies, they have solar power, they have redundant communications channels, they lease space, and that brings their capex to around 10 to 15k per station that they newly install, also including the labor costs. So they have teams, they plan a network rollout, they have people driving there, installing those stations, lease agreements that need to be signed. So it's quite an effort to do. Whilst in a DePIN mode, all people need is access to a number of such devices, which cost somewhere between $200 to $1,000, depending on how easy how plug and playable they are. You can even take a Raspberry Pi, put a Docker image on it, get an AliExpress Unicore COM module, and use that. So bill of material of around $200, and you're part of the network. Or then the other extreme is high-end IP67 weatherproof stations outdoors for $1,000, $1,500, and the whole range in between. So the capex in a DePIN mode is about a factor of 10 lower, 10 to 15. The maintenance cost, if you operate a station at your home, you typically do have network connectivity through a Wi-Fi or a LAN. The power consumption is like 5 watts, so that's hardly measurable. So the actual operational cost is relatively low. So that means a station in a network comes somewhere towards, say, $1,000, give or take how much effort you spend into building it yourselves versus having a plug-and-play solution. And this actually allows getting around those limitations that you have if you go as a traditional provider, where you have 15k of investments and say $1,000, $2,000 a year for your OPEX. By having this distributed and having it lower cost to start with, the quality of the data is comparable. I mean, it's not on the same level as the high-end stations are, because typically then those high-end stations, they also have a very rigid monumentation. They have rigid calibration procedures. We're getting around many of those things by calculating and by measuring and by compensating those things in the cloud. We cannot do this on chain because the data amounts and the latency requirements would be too stringent. But we're getting around many of those more traditional calibration procedures by in the onboarding process, in the validation process, as we take on new stations.
And what about scale? You mentioned every, whatever it was it 10 miles or was it 100 miles?
We want to have a station every 15 miles, every 20 kilometers.
In every, is that but diameter? Or is it sort of
correct. Now the thing is, if you remember, helium had like a hexagon setup, so you would have those hexes, and you put a station there, and there will be certain rules if there's already somebody in that station and not. In the GPS domain, we are our goal is to have a global, evenly distributed network, because it's not a data communications network. So we don't need to have more stations at areas where the usage of the data is higher.
There's no benefit.
There's no benefit. But what we need is a threefold redundancy, because if those stations are operated by individuals, anything can happen on that system. Power can go down, internet can go down, the antenna can break. So we are looking for a threefold redundancy, with the goal of 20 kilometers. Now, it's not such that after 20 kilometers, it's not black and white. So performance degrades. It takes slightly longer for a robot or a drone to be more accurate if it's 25 kilometers out, if it's 30, if it's 50 kilometers out. At 100 kilometers distance, it gets critical. It can take even minutes in order to reach that level of accuracy, but it's slowly degrading. So we have in our tokenomics and in the way we reward, we're measuring the number of stations within certain areas, and we're toning down the rewards as a function of the redundancy amounts. So if there's 3 stations within this more or less the same area, they all get the similar amounts of rewards. If a 4th station comes in, then there's a ranking amongst those stations, depending on the quality and the investment, essentially, of how good a piece of equipment they have, times the availability, so times the uptimes that those stations have.
Really interesting. So help us understand then, since you've mentioned it, the token economics piece of it, and the economics. I think that's a critical piece of DePIN networks overall. And I think also, just to backtrack, you've mentioned the capex reduction from 15,000 to 1,000, but I'd actually argue it's almost 15,000 to 0, because that capex isn't borne by you at all, by the company at all. It's borne by the community, right? So it's even a greater reduction.
Yes and no, because you need to look at the whole ecosystem, right? We're only the same boat. We're building up the tokenomics to achieve the right incentives and the right behaviors. But in the end, we're only the same boat. I mean, it's our goal to have people build out that network and have them participate in the success through the means of a token, a value appreciating token. So we do look at that cost. You need to also keep in mind, we're looking for a redundancy on the level of stations. Whilst traditionally those providers, the established industry, they build redundancy into the box. That's why they have redundant communications channels, redundant power. Whilst we'd rather have more people operate those stations instead of one station being super redundant. That's why we are looking at a threefold redundancy. So from your 15K to the 1K, it's actually 15K to 3K, because we'd like to have a threefold redundancy, ideally. So 3 guys in a certain area. Now the tokenomics, as such, is pretty straightforward, and you see similar tokenomics in almost any of the DePIN projects. With a supply side, we're issuing tokens on the basis of the quality of the data, the availability of the data, and the redundancy level, so the location scale, if it's overpopulated or not. And we're doing that on the basis of days. So every day that you're contributing data to us, we're issuing tokens. At the moment, our token is not yet listed, but we are issuing points on the Solana blockchain. The token is called Bono for Beta Bono token. And we're transitioning to the actual token, which is then also be traded in the course of next year, going from the Bono to the Ono and doing an airdrop for the early Bono holders. So we've been doing that already since a year. We've been growing the network to about close to 4,000 stations at the moment, and a vast, quite a variety of stations, from individuals who buy such boxes to existing networks who just can inject their data into our network and see it as an additional monetization, to professional networks who operate, say, in a region. I mean, Holland is a good example. There is a national network, and those people, they provide us the data of the network that they do for local business. They also provide the data to us. We give them the token because we're an additional sales channel to them. So that's the token side on the supply side. On the demand side, we are serving a traditional industry, an industry which is not used to crypto. Actually, in many cases, they don't want to hear about it. And if they hear about it, then they talk of FTX and scam and all sorts of things. So we're not necessarily promoting that. We are not hiding it. But we need to build bridges to that Web2 world so that people can come with fiat, with a crypto, with a credit card, and get access to the service. So we have a fiat interface where the actual revenue, so when people buy the service, will translate into token value appreciation, because organizationally we are an association, so we cannot have a bottom line, a profit anywhere in the system, because we are a Swiss organization which is non-profit by definition. And through that, all the value that goes into the system goes directly into the token value appreciation, either directly because people buy the token and convert this into data credits that they then can use to use the service, or indirectly by a buyback and burn mechanism that we have in the system.
So help me understand the buyback burn and how, I think that is one of the unique components of DePIN. And I think that is actually what I love about buy burn, is that no one else needs to find out about your project. Your token holders could stay exactly the same number they are right now. And if you're successful in achieving revenue, right, the association is just a constant demand for that token, buying and burning it, depending on the numbers, which I want to get into. And so what I love about that is it sort of upends the traditional crypto economic system where you have to promote and you have to find new buyers and you're always out there trying to promote it. Buy burn means you just generate your revenue, you work on your business, and everything else just happens because you are the demand because of the revenue. And I think that model, 2025 may be the year that starts to actually kick in and people start to realize that. But we will see. How clear is that? Is that division, the buy burn versus data credits? How specific is that in your setup?
It's deeply built into the approach that we're taking, and it's the essence of the economy. If you take out people who buy the token for investment, for hodl, for speculation purposes, in essence, what you're building is an economy where you can reflect the token value, or where the token value reflects net present value of your project. So if you look at it from a traditional finance perspective, a net present value analysis corresponds to the value appreciation if you would take out speculation and investments and hodling and all those more DeFi oriented elements. However, there's a strong part also on the token as such. People who invest in the token, whether this is investors, whether this is consultants, whether this is the team themselves, but also retail investors, which backed the system in the early days, because initially you have that equilibrium that you need to reach between supply and demand. And only once there's a good enough supply basis, a sufficiently dense network in certain areas, demand will grow. So there is this equilibrium that needs to be reached, which is being bridged by investors.
And so then help us understand to that point, which I also think, one of my talks I gave, I said, DePIN is not a meme. And I think that is kind of exactly what you're talking about. Frankly, some of us wish it was a meme for a while, right? Memes have been doing great. But I think, over the long term, we're going to decouple as an industry from that meme concept, because of exactly what you're saying. One of my thesis is that because you're generating revenue, professional investors, traditional investors will be attracted to the space because they can understand it in a way they can't the previous ones and evaluate it. So I think we're totally, it's great to hear everything you're saying. Help everyone understand the scale here, revenue of what you guys can generate. How big is this industry? What does this mean for what you're capable of generating in terms of revenue?
There is several market studies which talk about the overall GPS industry and how big it is. At the moment, it's about 150 billion euros in hardware revenues and around 200 to 250 billion euros in service revenues. Now, service revenues are all sorts of fundamental services, but also added value services, things like maps and licensing of those maps and various things that build on top. If we zoom in to the actual correction data, so what makes a GPS receiver more accurate, you'll see that this is about 10 to 20 billion of revenue today served by an existing industry. And in there's a number of specializations on top of the underlying reference network. So our SAM, so served available market, in our estimation, which is a bottom-up estimation, is about 1 billion euros that we can address in the coming 2 to 3 years. Because what we're doing is we're providing a single base RTK network. That's the technical term for having stations and providing that station data just for then doing something on top, either directly consuming it or consolidating it. There's additional value add by doing the consolidation, by doing a interpolation between data, by broadcasting it through satellites, for example. There's larger players, they broadcast such data through Inmarsat geostationary satellites, and for that they need to compress it. But that underlying network that we're working on, we believe it's about a 1 billion euro opportunity that we can address in a horizontal approach where the existing industry can build on top.
And is your pricing similar to existing centralized competitors, or are you priced at a discount because it's a newer service?
There is two aspects to it. One is the actual cost of it, and I think more important is what is the business model, how it is being monetized. If you look at the traditional providers, if you go and buy a service, they're going to sell you a year worth of service or a month worth of service. You have a fixed amount of time that you can consume their service per device. So you pay per month per device that then consumes the service. And if you have 10 devices, you can pay 10 times. If you don't use the service, if you only use the service one day in a month, you still pay a full month. Now, what blockchain allows us to do is have a very fine-grained microtransaction-based pay-per-use business model. We're actually calculating on a per-second basis. And we're also offering it in a pay-per-use model because the cost of sales through chain, and we are on Solana, where the transaction cost is low and it's high throughput. There we can just deduct data credits on a per usage basis, and that is very attractive if you're a farmer and today you need to buy a service and you need to sign up for a service for say $400 a year, and you're not using that service 80% of the time, you're paying for something that you don't use. Whilst in our case, you are paying, if you need it Monday morning, you're paying for what you've used on Monday morning and not for the full week or for the full month. Now, from an absolute pricing perspective, with that pay-per-use model, we're very attractive for occasional use, for infrequent use, for as-you-need use. For service providers, so the existing industry who wants to densify their network or geographically expand, there is plans where there's discounts which make it highly attractive and much more cost-effective also for them to consume a stream from us rather than buying it from somewhere else, from a traditional provider, or more importantly, operate their own stations. So, and with thanks to on-chain, the economics being on-chain, we can play those business models in a very efficient way.
Really interesting. And so what that also means is that the hurdle to sign people up is pretty small because it's a pay as you use for a consumer. It's not you don't have to sign up for a year-long contract. You can sign up and just you pay as you go, which is you'd think would reduce the hurdle.
Totally.
One thing I think is I'm kind of curious about. This gets a bit more into the business side. A lot of Web3 projects are technology led. We developed a lot of Fluence as a decentralized compute platform, a lot of years spent building technology, but we have since really over the past 6 months been investing in business development, in marketing, right, in the whole traditional business side. So I'm guessing from where you guys are, that is the real focus of the business now is the actual sales side of it all and getting customers. I'm just kind of curious to hear how you think about that because that, historically the crypto projects were build an L1 and it will come, right? And DeFi offer rewards and give some high yields and money flows in. And we're operating in a bit of a different environment.
In essence, yes, that's the focus is on the business development side. It's building out the demand side. It's bridging the Web3 approach, which we are in essence, to a Web2 world and explaining and building bridges for a Web2 world, which is a lot of business development. It's a lot of education. It's a lot of storytelling and to explain how that works. So at its core, we are doing a business model innovation, not so much a technology innovation. There is one aspect, though, or maybe two aspects. Doing large-scale RTK networks with the goal of 100,000 stations on the inbound side, on the node side, but also millions of direct connections to devices. It's a scalability problem, and it's something that can be solved, but it's a significant effort in order to make it from the cloud side that's scalable. That's also the reason why the actual GPS data is not going on chain, because it would be too much, it's too latency critical. So that is a cloud system where the system interfaces with the chain, with the blockchain to settle the economics. So I think that's the technical challenge one. The bigger challenge is we are approaching the GPS industry with a hardware agnostic mode. So you could build a device. So we could build a Onocoy device, which says Onocoy on the front and which only works in the Onocoy network, or even a second brand, and but it only works with Onocoy, and we have control over the device that people buy. We may even get a revenue stream from selling that device directly or through a third brand and lock it up. However, we chose not to do that because there is a large industry of people who build such devices. There's no point in reinventing devices that have been built for the last 10, 15 years. So we'd rather use those existing providers, those existing supply chains with the standards that they have and the interfaces that we do. So in our setup, nothing on the device is proprietary, which also comes with the intrinsic problem that anyone could inject data, which is either synthetic or somehow cooked data that is not actually coming from a physical device. And if you're asking for technical innovation in that project, identifying what is coming from an actual physical device and what is synthetic data that somebody builds a script or trains some AI to generate such data. That is a challenge, but it's a challenge that is solvable, and we've proven this again and again. And it's also in the broad context of GPS. It is a systematic problem that needs solving. Spoofing, which is a technical term in the GPS industry, is omnipresent. If you look in theaters of war, you see a lot of spoofing signals where even over the radio link or over the RF, a lookalike GPS signal is being broadcast, which then the receivers in the field pick up and are being misled. So what we are solving, and a lot of our research and a lot of our development also goes into that, is the algorithms to figure out what is actual physical data and what is not. That can be done on the basis of geospatial characteristics on the data, of atmospheric characteristics that we can extract, also on several aspects that you can look in the data and also verify it in real world whether something is physical. But coming back to your question, in essence, it's a business model innovation, but with some pretty interesting, also scientific approaches that are being solved.
One question you made me think of, and this may be a little bit too specific for some, but I got to ask it anyway. You mentioned GPS is obviously from geos, right? Geosynchronous satellites in geosynchronous orbit, which are, I forget, like 33,000 or something miles above the Earth. To Starlink, will Starlink offer service because those satellites are so much lower that makes this not as necessary because the latency is so much slower or lower?
Yes. So the satellites of GPS and the other major constellations, they're about 26,000 kilometers above us. So they're not geostationary. They have an orbit time of twice a day. So they're coming around. The geostationaries would be another 10,000 kilometers further out. But it's more or less, they're far away. So the Earth diameter is 6,000 kilometers. The satellites are like 3 times the diameter away from where we are. There is a class of projects typically under the umbrella of LEO PNT, so low Earth orbit position, navigation, and time, where companies build up networks or satellite systems more on lower cost, near Earth orbits to provide also navigation purposes, navigation signals. You all specifically asked about Starlink. The Starlink signal can be used for navigation purposes, although they have not been built for that, but they're not optimal because the frequencies at which they're sending and also the signal modulations that is being used is optimized for data communications, which is quite the opposite of a navigation signal. A navigation signal needs to be precise because it's all about time measurement as it comes from the satellite down to Earth. But there is a number of companies which build up their own LEO constellations, typically a few hundred satellites. Xona in California is one of those companies where they're building out their own network of LEO satellites. And it has also some nice properties because they're low Earth orbit. The dynamics as observed from the surface of the planet is relatively high. They come and go within 10 to 20 minutes. They come into view and they leave the field of view within that, and those dynamics themselves are helpful for many applications on the
planet. So does that, and that is the basic point is Starlink is not optimized for location. There are LEOs that do this, but
Correct.
That's a different service, and that there's still not going to be, the service you offer is still highly competitive with anything those guys could come up with, and you still have the whole capex reduction. You're not putting satellites in the air; you're just using the signals. So, from a capex and cost perspective, you're still materially lower, you would imagine.
Yes, I mean the LEO PNTs, they're in competition with GPS. GPS and the European, the Russian, the Chinese counterparts, they're free of charge for civil usage. So if you build up a private network, you have pretty intense investments that you need to do in order to bring up those hundreds of satellites, and you need to recover that from service fees for the core satellite signals. So you need to have some added value on top that people are willing to pay for, which can be on the level of integrity, on the level of security, possibly on the level of performance, although performance of GPS, and especially also with correction improvement services, which are cost effective, like what we are doing, there's the value add of private constellations is probably somewhere else. And the data communications constellations like Starlink, it's not their focus, and the signals are not made for that, and they're far away frequency-wise. So you cannot retrofit an existing GPS receiver that you have in your car with Starlink navigation capabilities because it already fails at the antenna. The signals are just too far away from being receivable by those antennas.
Gotcha. Another question for you. You mentioned the difficulty of scaling to 100,000 stations as an example, and that's possible but difficult. Does this become, and I know there's other providers out there like GeoNet and others, they're doing something similar to what you're doing. So do you end up in a world where there's multiple competitors globally, or do you think you end up with regional, right, where one's in Europe, focused on Europe, and one's in the US, so the stations are denser and the network is more specific to a region? Is that, and because customers are more regional potentially, how do you think about, because this is, we're in a new world, right? We used to have DePIN one project per sector. We're now moving to a place we're going to have multiple. So how do you think that shakes out?
Um, the way we are positioning ourselves as a horizontal layer, that needs to be a global system. Um, and there is a need for a open, hardware agnostic infrastructure, but also an open and service agnostic demand side. So we're not going into providing the services ourselves. For that, there's an existing industry. And so we believe a horizontal positioning on a global scale is what is needed. And sure, there is existing, and there will continue to exist, private networks which are vertically oriented, which typically focus on certain use cases, whether this is in the agricultural domain or the automotive domain. And they have a private network because they need a more rigid control for the use case that they have, or they have very specific business models for those use cases. We believe, though, on a more layered structure, where there's an existing industry that can build on top and below also on the hardware side.
Good to know. Let's talk for a second about governance. And I think one thing that the Fluence project shares with Onocoy is we were both governed by Swiss associations, and so just give people a little understanding of what an association is and why you chose it. I think a lot of people are more familiar with foundations or Cayman entities. So I think that's just an interesting commonality that we have, and I'm curious your perspective on it.
Yes. So we are an association, which is a legal vehicle here, typically used for football clubs and for stamp collectors and such interest groups. But it's also being used in large-scale operations, like the FIFA, the World Football Association, is at its core, it's an association. Not that this is necessarily a good reference, but it is also a tool that allows you, or a legal entity that allows you to build up something in a non-profit manner. And we believe, and also the regulatory system here allows that this is the right approach for a system which is owned by a community, which is regulated by governance. You can consider it like a national legal entity set up that can be turned into a DAO at some point in time. It's like a real world, a paper-based DAO, if you want. And that's also our approach to it. So we started with a association. We have a governance structure. We have the voting schemes, also with some innovation on that level. For example, square root based voting, in order to make sure that not a single large token holder can dominate and steer the project in the wrong direction, which we believe is important if we want to serve as a utility to the whole industry. We need to have measures in place that couldn't somebody like a big existing and incumbent come with a lot of money, just buy up half the tokens and then shut it down because it's not in their interest. So we've built methods into the bylaws, in the association, and also further on in the on-chain governance that avoids that by only counting square roots of votes, which equals out balance of power, gives more power to small token holders. And through that, this association scheme allows that, and it's a good and a valid and a regulatory compliant way how such projects are being made these days.
Really interesting. I mean, listen, the Fluence Association, we were worried about that as well. We took a different approach. So the square root is a very good one. We did a different one where we have a governance committee that can veto any on-chain vote, but that governance committee is elected by the community every 2 years, right? So they can only veto for up to 2 years. And so if someone really wants to take over, you theoretically could take over that governance committee, but it'd be a two-step process. You'd have to oust the committee and then put the on-chain votes onto it, which is certainly possible, but was our way of kind of protecting against that, because I think that is a very real risk. And as these projects get more valuable, as treasuries get more valuable, I think you will see more potential attack vectors and potential and risks.
And I think it's also important because we'd like to participate, we'd like to have the existing GPS industry participate in our project, not only on either the supply or on the demand side as a consumer or as a provider of hardware, but also as a strategic tool for them to build their business further. We'd like to welcome them also as investors, and for that we need to make sure that not one entity can dominate that. And that's why the square root voting, we've introduced that. We also have a governance committee which is being elected by the association, and through that voting mechanism, it doesn't formally have a veto on things that happen, but there is that means of delegating votes and of the square root, which gives us sufficient protection for such
really interesting. Well, you mentioned helium as being one of the inspirations, one of the early projects that's kind of brought raised your awareness to this whole sector and was some of the inspiration. Are there other projects that you like, that you follow, that you're impressed by? Anything else you want to draw attention to in the DePIN space for people who are paying attention?
Sure. I mean, the Helium project, I think, is the most well known, and it's also the Lighthouse project, and we've studied it quite deeply, and because it proved what is possible with a crowd incentivized setup. It also showed the limitations, because there was no demand. So the actual usage of the initial LoRaWAN network that they built out, there's hardly been any demand. So the actual revenue, so the demand side need for the service was just not there. And I think that's also the biggest learning out of the Helium project. And we believe there the GPS industry is very different. There is an existing, I mentioned the number 250 billion euro business out there, and we can address a portion of that, which in the LoRa case was just not the case, because LoRa is one out of many IoT communication standards, and they're all competing, and they're all pretty low revenue per se. The other learning out of the Helium project was the hardware side, or the economy as such. The Helium project early on not immediately, but quickly grew. It overheated. And so we've built some measures in place to avoid that this happens, so that things stay within reasonable control. And so the tokenomics had some means to control that, but also on the hardware side. Back in the days when helium miners cost you $5,000 because you could make a fortune within weeks of that, the actual sellers of that hardware, they made a lot of money. Also, the Helium project themselves, which was the revenue that they did through activation fees that had to be paid by the people purchasing the hardware. So the actual revenue that they did was on the back of the miners. In our setup, we cannot do that because the hardware is either already out there, so there's an installed base, or it's new hardware and we don't want to add additional cost on top of the hardware. We'd rather want to go broad. I think it's also a more transparent play if it's very clear who participates to what extent on what part of the economy. You asked about other projects. I mean, we continued following Helium. Helium also moved to Solana, went away from their own blockchain. That's why also one of the reasons why we moved to Solana, because we could also see how they're using Solana in their setup, so we could reuse parts of it. There's also Solana has become a bit of a hotspot for DePIN projects. Before DePIN specific chains such as Peak started to appear. There is a number of projects. Hivemapper is an interesting example. They also need high precision GPS in order to do what they're doing. But generally, I would only look at DePIN projects which have a real demand side behind it. So if you're inventing a new DePIN to solve a problem, I think the key question to ask is, what is the demand side? How big is it and how big can it grow? And if you look at projects which measure some properties, say noise pollution or say air or air quality, how big a market is for data as such. And even with the wildest of fantasies, if you imagine new use cases, how big could that be? I think that demand side should give the value of a project. Because ultimately that's what it is. The value of the token or the FTV of the overall system should be in some relation to the net present value out of what a project can address. So I would take this test. How big is the demand side today? How big can it grow to see where are, in the long run, the most interesting DePIN projects?
Understood. Totally agree. I mean, and that's also why Fluence is targeting compute. It's a big, there's a lot of demand for compute.
Absolutely.
But it's a different challenge, obviously. Love to, listen, appreciate that. How do people follow Onocoy? How do they follow you? How do they sign up to buy and install a station? How do people get involved here?
So we have a fairly active Discord community where people discuss the project, where they also exchange installation tips, where they talk about using Raspberry Pis and electronics and build it yourself. We are active on Telegram. There's an Onocoy channel. We are active on X that is addressing the more Web3 side of things. But because we're also playing on, or the demand side is a more traditional market, we're also pretty strong on LinkedIn, press releases, websites. So you find us at www.onocoy.com. There's on the top, there is also links to Discord, to our Telegram channels, to our LinkedIn profiles.
Awesome. Well, Daniel, thank you so much for joining. Thrilled to have you here, and look forward to having you back on once you've got the token transition to complete and you've made a couple more steps. I think there's gonna be a lot more to talk about. So really excited to hear about additional traction, which I know is coming. I think 2025 is gonna be a big year for the industry and certainly for Onocoy. So thrilled about that. Thanks for being on.
Thank you, Tom. Thanks for the opportunity. Appreciate it.